All right, so for the top three, we're going to have to get another sheet of paper because I suck and didn't put this up on there. So for number one, with this spec here, telling you what quadrants we're in. So you first have to realize that if sign's positive, your only options to draw your pictures were in quadrants 1 or 2. And so for this one here, it's telling us to draw your triangle in your second quadrant. Sine would be opposite over hypotenuse. So you'd have to use Pythagorean theorem to find your missing side. So you're going to do your a squared plus b squared equals c squared. And when you solve that, you should get 4. But you see how 4 is pointing in the negative direction? So it's actually a negative 4. Your x values are negative in here. So then from there, you just have to write out your missing stuff. So we know what sine is. I'm just going to go ahead and rewrite it. So cosine, tangent. So my sine is opposite over adjacent. Opposite, yeah. And opposite over hypotenuse, adjacent, and then opposite over adjacent. And then you would just flip them for your other trig functions, secant and cotangent here. So we get negative 4/3, negative 5/4, and 5/3 for those answers. So for a tangent here, it's between 0 and pi over 2. So tangent's only positive in the first and the third quadrant. So if it's positive, it had to be either quadrants 1 or 3 to draw it. So this is just a quadrant 1 question. It's opposite over adjacent. So we're going to do Pythagorean theorem to find our hypotenuse. So that is 73. So square root of 73 is our hypotenuse. And then we're just going to go ahead and write out our trig functions. I'm lazy, so I'm going to put it over here. So write out your sine, your cosine, tangent, and stuff. And then your angle is always down to the angle by the origin. So it's going to be 3 over square root of 73. And these are all positive values, 8 and 3/8. And you flip them for this. And remember, if you're doing the ACT or stuff like that, they're probably going to want you to rationalize that. So that's the same thing as this answer right there. So number 12, this doesn't actually, or 3 doesn't actually make sense because sine's not negative in this quadrant. So let's make this 3 pi over 2 to 2 pi. And then that puts us in the fourth quadrant. So for my fourth quadrant here, so I said 3 pi over 2 to 2 pi. So then we're going to have sine would be opposite over hypotenuse. So do 144 minus 121. So this side is the square root of 23. We're going in the positive direction, so I'm going to make it positive. And then we just need to fill out all of our trig functions. So we get negative 11/12. So this would be square root of 23/12. And then you flip them for the other side. Again, you can rationalize that denominator, but I don't need you to. I only need to do it to match answers on the test. There's nothing wrong with a rational on bottom. Right there. Okay, so you can stop if you're just, we're going to do just a few more questions if you're just doing the like half video, whatever. So we have that for it. And now we're going to do simplifying trig. So simplified trig, I will never test you on these. All right, so those will never be on a test, but I have them there because a lot of questions have those as rules on there. But I took them off of all test questions because we don't actually need to know that for calculus or like to be able to do our stuff on whatever. And then you do need to know these, and the Pythagorean identity should be the only new thing because you should know your reciprocals. Like you know tangent, sine divided by cosine. You should know the reciprocal of sine, the reciprocal of secant, the reciprocal of cotangent. You should already know these reciprocals. That's what we worked on all last chapter. So the only thing that should be new is this one right here. And so we're going to go ahead and put that there. So what you can notice here is that if sine squared plus cosine squared equals 1, if this is a true statement here, then also sine squared of theta would have to equal 1 minus cosine squared of theta. And I could say cosine squared of theta equals 1 minus sine squared of theta. So it's just rewriting the rules. So you can do that for all of them. So all 3 of these are equivalent to each other. Just so like tangent squared theta equals secant squared theta minus 1. Right? Right here I could have 1 equals secant squared theta minus tangent squared theta, and so on. So I'm going to use these properties to try to simplify some of these right here. So the things I do is I look for Pythagorean identity first. I change everything to sines and cosines, and then I start reducing it. So I don't need, right here, 1 minus cosine squared. Remember I just proved 1 minus cosine squared is the same as sine squared. So I'm going to replace this with a sine squared. So I'm going to have sine x times sine squared of x. So our answer here is just sine cubed. So second one, we're going to use, move this down a little bit, and over. So tangent, this right here is this right here. So that's the same thing as cotangent. So this is the same thing as cotangent of x over cosecant of x. And now I'm going to change everything to sines and cosines and see if things start canceling for us. So cotangent, using this right here, that property, we're going to say it is cosine over sine. And then this is the reciprocal of sine. So we never divide by a fraction. We multiply by its reciprocal. So I'm going to flip that, make it sine of x over 1. So our answer is cosine of x. All right, so number 3, I might have to get another sheet of paper out. Cosine of pi over 2 minus theta, that's just the sines answer. So it's really sine of x. And I'm going to change cotangent to sines and cosines again. So cotangent is cosine over sine. Multiplication, so you can make them both fractions if it helps you. And then cross. So your answer is just a cosine of x again. So what I'm going to do here is I'm going to factor, because I see a secant theta is in each term, so you can factor it out. So we're going to have secant theta, tangent squared theta plus 1. And now this right here, I'm waiting for the video to catch up to me. Okay, this right here is just a Pythagorean identity. The 1 plus tangent theta, 1 plus tangent theta. So I can replace it with what it equals. So secant theta times secant squared theta gives me secant cubed of theta. All right, so number 5 down here, this is just the rewriting of the rule right here. See, secant squared minus tangent squared just equals 1. All right, here I'm going to first change this to just the sign. So I get secant x times sine x plus sine x over 1 plus secant x. And then I'm going to factor out a sine x on here. So when I factor out the sine x, I'm going to get a secant x plus 1 over 1 plus secant x. Cancel them. So your answer here is just your sine of x. All right. To verify, you only work one side. So what I'm saying is, like, I'm giving you the answer and you're just showing that I have the right answer. You cannot use both sides of these equal sign. You can work left or right, but not both. So we're just going to work left here. So I'm going to change all these to sines and cosines. So sine, and then that's 1 over sine, and that's cosine. Now once I have them all changed, you should start seeing a sine cancels, a cosine 1, and we're done. Sometimes I put a smiley face. Mathematically, they put 3 dots at the end to say that we're done with the proof. I kind of like a smiley face or a check mark. Makes me feel good about myself. So this right here, I'm going to use the fact of secant squared. Right here is 1 plus tangent squared. So I'm going to substitute that. So I have 2 minus 1 plus tangent squared of theta. Oh, it's an x of an x. Now I'm going to distribute in my negative. So 2 minus 1 minus tangent squared. 2 minus 1 is just 1. And we're done. We got to the other side. So you'll be done. All right, and number 3 here, this is a Pythagorean identity. Cosine squared plus sine squared right here. That equals 1. So you substitute the top for a 1. And then the bottom is also just an identity. That's secant. So I'm going to put secant squared. The reciprocal of secant squared is cosine. If you flip secant, you get cosine. So then this just equals cosine squared. And we're done. And so the last one over here is just a trick. The only way to solve this is to multiply by a conjugate. So remember, the conjugate is when you do 1 plus the answer on both sides. So if I FOIL out the bottom and I don't FOIL out the top, just because you very rarely ever FOIL out the opposite of the conjugate. You only FOIL out the part that is a conjugate. So this should be 1 minus cosine squared of x when you FOIL it out, because you get a minus cosine and a positive cosine, so they'll cancel for you. So then this ends up being a Pythagorean identity on bottom. So remember 1 minus cosine squared is right here. 1 minus cosine squared was the same as sine squared, just rewriting it. So I'm going to put this as a sine squared. Now look, I have a sine on top and a sine squared on bottom, so that will cancel with one of these. And I'll be left with 1 plus cosine of x over sine x. And then I'm done. That's all of them.